Alright, so up next, number 18 on the January 2020 paper, appreciation and depreciation. Well, they normally ask a little more simply than that instead of using the compound interest formula, which you could use for appreciation as the same thing. So here they normally only do a year or two, right? Most of the time it's be a year, and usually all the questions we have so far on the paper is depreciation. So the value of the car is $12,000 and they're going to depreciate at a rate of 10% per year, meaning losing 10% of its value. What will be the value of the car 1 year later? So 1 year later, it's going to lose 10% of its value. So I have two ways I could do it. Find 10%. Zeros cancel out there, 10 in common. So it's going to lose $1,200. So 12,000 minus the $1,200, which it lost in its price. Borrow from here. 0, 0, 10 take away 2, 8. 1 take away 1, 0. So 10,800. The next way you could do it is in terms of percentage. So if it lost 10%, that means now it's 90%. So 12,000, only 90% of the value of the car remain because it lost 10% out of the 100% that it started off with. And 1200 by 9 are still going to get 10,800. Let me look at some others. So same idea here. At the end of a year, cars worth 5% less than what was worth at the beginning of the year. So at the start of 2014, it was 10,000. How much are going to be at the end of 2014? So I could find 5% of the 10,000. Two zeros cancel out. So it lost $500. So the car cost $500 less. It lost $500 in value. I want to subtract that, 9,500. Or since it lost 5%, it starts off at 100%. It lost 5%, so now it's at 95%. 100 take away 5, so I find 95% of the 10,000. Two zeros cancel, 95 by 100, 9,500, whichever way you prefer. And this is just a different variation of the question. Starts off exactly the same if you notice. At the end of any year, a car is worth 5% less than what was worth at the beginning of each year. If a car is worth 9,500 in December, not January, then what was the value in January 2016? So they want me to do the reverse now. So this lose 5% a year, so that means by December it already lost its 5%. So that means 100 take away 5, it's at 95% in December. So again, we're doing a reverse of this question here, and the answer is going to be what we started off with, by the way, right? So just a reverse of that earlier question. So after it lost 5%, the car value is now 95%. And the 95% is already 9,500 because by December it already worth 9,500, it lost the 5%. And I want 100%. So just like before, I find 1%. 9,500 over 95, which is 100, and I don't want 1%, I want the value of the car when we started off, which is 100%. So 100 times 100, and I'll get back with 10,000. So it's just a reversal at that question. I have a little mark here for May 2018. I left it out, but I want to work it out because I find it's an important question, one of the harder ones on this as well. Mr. Jones bought a car for $64,000. The car depreciates by 20% in the first year and then 10% every year after that. What was the value of the car at the end of the second year? So I have to do it year by year. So at the end of the first year, so it started off at 64,000. By the end of the first year, it lost 20%. So 20 over 100 times 64,000 over 1. Or could I find 80% of 64,000, whichever you like. Zeros cancel off there. So 6,400 by 2. 12,800. So it lost that value after 1 year. So the price of the car after 1 year, 64,000 minus 12,800. To borrow 0, 0, 10 take away 2, 51,200. So that's after 1 year. So that's only 1 year. So at the start of the second year, the car worth 51,200. But by the end of the second year, it's going to lose a further 10%. So you can see why this is one of the harder questions as well, because you have to do it twice. So it loses an extra $5,120. So it was $51,200 at the start of the second year. And by the end of the second year, losing $5,120. I want to do my subtraction stuff. You can check it yourself. The answer is going to be $46,080. Right? So up next, number 19 and 20.